Yes, student, today's topic which we are going to discuss is physical properties of alcohols. Okay, that is after method of preparation of alcohol. Now we will see the properties of alcohol. Here what? Physical properties. So student, the physical properties, the first physical property is what? State, that is physical state. Okay, color and what? Order. Okay, state, color and order. Lower members of alcohols like what? Methanol, ethanol, propanol, butanol. These are called what? Lower members of alcohol are liquid in nature. Liquid in nature. This is due to what? Now why? The physical state caused by the magnitude of intermolecular attraction force. This is due to the strong intermolecular attraction force. Intermolecular attraction force. Now, which intermolecular attraction force is there? This is called hydrogen bonding. This is called what? Hydrogen bonding. Okay, student, you know that the hydrogen bonding is the strongest intermolecular attraction force among all type of attraction force. Therefore, although they are derived from alkane, but in alkane there is only weakest intermolecular attraction force, which is what? Dispersion. But in the alcohol there is what? Strong bonding is present, which is called what? Hydrogen bonding. How this hydrogen bonding takes place? Say R, this is what? O, and this is what? One of the hydrogen. And the next one is R, O, and this is what? Hydrogen. So what? In oxygen there is fraction negative charge. In hydrogen there is fraction positive charge. So between H and O of one and second molecule there is what? Hydrogen bonding is present. Therefore they come close and thus they becomes what? Liquid in nature. As the molecular size, that is what? You can say higher member. Okay, and molecular mass increases, okay, van der Waals attraction force increases. Van der Waals attraction force increases. So higher members becomes solid. Why? Because in the higher member, now the two type of forces will work. First of the force is what? Hydrogen bonding, and the second force is what? Increase in the van der Waals attraction force. Student, van der Waals attraction force applicable, that is becomes more, okay, effective in the case of molecular mass is bigger or molecular size is bigger. So the higher member have higher molecular mass and bigger molecular size. Therefore, the van der Waals attraction becomes very high and thus they becomes what? Solid. Now about colors. Okay, alcohols are colorless with pungent, we can call it what? Alcoholic smell. This is called nose irritating smell. So whenever there are what? Alcohol in our surrounding. Okay, we generally used to close our nose because it shows what? Nose irritating smell. So this is what? First property. Second property is solubility of alcohol. Now student, the solubility we have to check in two part. Which two part? First part what? In water. Solubility in water, because water is a universal solvent. So very first, the solubility of any of the organic compound is first checked with what? Alcohol. So it is soluble or not soluble. Alcohols are soluble in water. Alcohols are soluble in water in all proportion. What is the meaning of in all proportion? That is what? That is, in 100 ml water, 10 ml alcohol can be dissolved, and in 10 ml alcohol and 100 ml water, again they can make a good and true solution. That means any of the proportion, you change the proportion of alcohol, you increase its proportion and decrease the proportion of water, or you increase the proportion of water and decrease the proportion of alcohol, in any way they dissolve. That is, they shows very good solubility. Now the question is why? So what is its answer? Because what? They follows what? Like dissolve like concept. Now what is it? That is in water, okay, as well alcohols. In water as well alcohols. Similar, hydrogen bonding is present. Similar hydrogen bonding is present. So when they mix together, again what? Hydrogen bond between, okay, water and alcohol forms, and alcohols form. That means what? That means, say, this is what? Water. What is this? Water. And now if you took alcohol, then alcohol is what? Alcohol is R, O and what? H. So there is what? Fraction positive charge, there is what? Fraction negative charge. So now between water and what? Alcohol, a new bond will form, and again this is the type of same what? Hydrogen bond, and therefore they are soluble in all proportion. Okay, so this is about what? A. About what? B. Inorganic solvent. Okay, organic solvent like what? Ether. Okay, what? Benzene. Ether and benzene, they are also soluble. Because why? Because alcohol is organic compound and this is also organic compound. Therefore what? They are again miscible. But the solubility of water is very high. This is due to same type of bond. Even in carboxylic acid, the alcohol is also highly soluble, because again the hydrogen bond forms between carboxylic acid and water, because they again having the similar type of bonding, what? Hydrogen bonding. So being intermolecular attraction forces are of same type, therefore they follows the principle what? Like dissolve like principle, therefore they are soluble. Student, actually if you try to make the solution of alcohol in water, you can dissolve any amount of alcohol and any amount of water with each other. Student, you also know that alcohol in itself act as a very good solvent, okay, and it is able to dissolve large number of organic as well as even sometimes inorganic substances, and therefore in the medical industries we are frequently using alcohol as a solvent. Yes, student, the next physical properties is boiling point of alcohols. Student, you should know what is boiling point. The temperature at which any liquid start to boil is called boiling point. This is the old definition. We have one more definition. When the vapor pressure of any liquid becomes equal to 1 atmospheric pressure, this temperature is known as boiling point of the temperature. Student, in the boiling point or in the boiling temperature, actually the force of attraction, okay, between the two molecules or more molecules which exist earlier, on increasing the temperature, this temperature gets breakdown, and therefore each molecule becomes what? Discrete molecule, that is becomes isolated, and being it becomes isolate, now they convert into vapor. So this is known as what? Boiling point. That means what? That means to discuss the boiling point, again we have to discuss which type of attraction force, means intermolecular attraction force, is present in the given organic compound. Okay, then we have to check the magnitude of that intermolecular attraction force. If the magnitude is strong, then to break down this attraction force will require more temperature, therefore they will show what? More boiling point. Are you getting? So alcohols have strong hydrogen bonding, so okay, require high temperature to break this force, therefore alcohols have high boiling point as compared to alkanes, to which they derived, okay. We know that alcohols are derived by the alkanes, so we can compare the boiling point of alkanes with the alcohols. Getting? Next one, comparison of boiling point of alcohols in homologous series. I think there is no need to explain you homologous series. What is homologous series? Increasing the number of alkyl radical in different alcohols and getting the series having the same functional group. This is known as what? Homologous series. So in homologous series, each successive two compounds have change of CH2. CH2, that is 14 molecular mass. As the molecular mass increases, the magnitude of van der Waal attraction force also increases. And if the magnitude of van der Waal attraction force will increase, the boiling point will also increase, because it requires high temperature to break down. Okay, so in homologous series, there is regular increase in molar mass by 14 by 1/4 unit. Okay, hence van der Waal attraction increases. Okay, thus boiling point also increases. And therefore alcohol have high boiling point, that is, say like CH3OH, the more boiling point will be of what? C2H5OH, the more boiling point will be of what? C3H7OH. All they are having OH, that is, all they will have same intermolecular attraction force, what? Hydrogen bonding. But as the molecular mass and the molecular size will increase, the magnitude of van der Waal attraction force will also increase. Therefore, the boiling point will gradually increase. Okay, third one, comparison of boiling point of alcohol with water. Okay, so water have high boiling point. Do you know? It must be known to all. What is this? 100 degrees Celsius. Okay. This is due to okay, strong magnitude of hydrogen bond, while in alcohol, okay, hydrogen bond is present, but of lower magnitude, okay. That means what? The alcohol have boiling point 75 degrees Celsius, that is less than the water. Actually, in alcohol there is one alkyl radical, say R. Okay, this R donates electron on oxygen. Therefore, the oxygen already become very high electron efficient, isn't it? Being it becomes very high electron efficient, it shows lesser tendency to attract another alcohol molecule. Getting? And therefore, the boiling point of alcohol is little lesser as compared to what? Water. Lesser but little lesser, not too much. Okay. Next one, comparison of boiling point of isomeric alcohols. Now, student, what are isomeric alcohols? So I told you they are having what? same functional group, same molecular formula, only their structural formula are different. Getting? Structural formula are different. That means what? Some of the molecule can be represented by symmetrical structure and some by what? Unsymmetrical structure. Isn't it? Symmetrical means like normal alcohols. Okay. And the branched alcohol means iso or tertiary alcohol. So, as the branching takes place, as the branching takes place in alcohols, okay, contact surface area decreases, okay. So boiling point decreases. Actually, I am not describing it too much. It is because in haloalkane this content is already explained and there will be the same explanation. Like here, if we consider about 3 alcohols, normal butanol, 2-methyl butanol and 2-methyl, okay, propane 2-ol. Now there are 3 isomers. Normal butanol, symmetrical molecule. Getting? So one of the symmetrical molecule can attract another symmetrical molecule with greater surface area. As higher the surface area, require more temperature to break this attraction force. Therefore, the normal alcohol, okay, that is the simple isomer, have the very high boiling point. If the branching takes place like here one of the molecule and here another molecule, now the contact area what? Decreases. And if the contact area decreases, to break this contact surface area require lesser temperature. And suppose if there are more branching, then the more branching having molecule becomes almost spherical. And you know that for spherical one of the molecule with spherical another molecule, the contact surface area will be very less and therefore they require lesser temperature. Thus what? Butane 1-ol have very high boiling point. Getting? 2-methyl propane 1-ol have lesser boiling point, while 2-methyl 2-propane-ol have very low boiling point. Getting? Student, not only these property of boiling point are compared, but we can compare the boiling point of alcohols with other organic compound. Like here I compared with water. Okay, here with what? Alkane. But even we can compare with haloalkane, which we studied in last chapter. Student, in haloalkane, the dipole-dipole intermolecular attraction force is present. Getting? But in alcohol, the hydrogen bond type of intermolecular attraction force is present. So now think, which intermolecular attraction force is stronger? Obviously, hydrogen bond. So being in alcohol, hydrogen bond is present, while in haloalkane, only dipole-dipole attraction force is there. Therefore, alcohols have high boiling point. But remember one thing, if we are comparing such molecules, then we have again focus on their molecular mass, because you know that the molecular mass also changes the magnitude of van der Waals attraction force. So if we have to compare the boiling point of alcohols and haloalkane, then the molecular mass of two molecules must have either same or comparable, that is almost same. Okay, we cannot discuss the boiling point of C4H9Cl with CH3OH. In C4H9Cl, there is dipole-dipole attraction force. in CH3OH there is hydrogen bond. So can we say the hydrogen bond will having high boiling point? In fact what? No. Why? Because in the case of CH3OH, the molecular mass is very low, the molecular size is also small, but in case of butyl chloride, the molecular mass will increase, the molecular size will increase. So however, they shows dipole-dipole attraction which is weaker than hydrogen bonding. Therefore, the increased molecular mass and the increased molecular size will increase the van der Waals attraction force. Therefore, its boiling point means the boiling point of C4H9Cl will be higher as compared to CH3OH. So I think now you understand the discussion of boiling point. Okay.